Alright, welcome back everybody. In this video we're going to handle examples 3 and 4 from the Taylor's theorem with remainder lesson. And this is a slightly flipped perspective from the last video. In those we were finding the maximum error. What we're going to do in these examples is we're going to find the intervals of x where the error magnitude is no greater than a particular value. Alright, but we're still using the Lagrange Error Bound. So we want our remainder, and we're looking here at a third order polynomial for cosine. And so we want the third order remainder. Come on. Wakey wakey time. We want the third order remainder. For some reason my eraser wasn't working there. Sorry about that little delay. And that has to be, the remainder has to be less than or equal to the maximum of the fourth derivative of the function times, and again this series is centered at 0. So we're looking at the max of absolute value of x to the fourth all over 4 factorial. Alright, and we're told here we want the error magnitude to be no greater than 5 times 10 to the negative fourth. So that's our error. We're going to put that in here. That has to be less than or equal to the maximum value of the fourth derivative. And if we take the fourth derivative of cosine of x, it's just cosine of x. And so on an interval centered at 0, the maximum value that's going to have is just going to be 1. And the maximum value of absolute value of x to the fourth is going to happen at the endpoints of the interval, which are exactly what we want to find. So we're going to leave that as absolute value of x to the fourth. All that over 4 factorial. And now we just need to solve this equation. And that's going to give us everything that we need to know about the interval. Or pardon me, solve this inequality. Alright, so multiply both sides by 24. And if I solve this inequality, I'm going to take the fourth root of this. So I want the fourth root of 0.0120. So 0.0120 raised to the 1/4 power. And when I write this, I want to round it out. Round it out. I just made a hand motion that you can't really see in the video. Sorry, it's been a rough morning. And so x needs to be in between positive 0.331 and negative 0.331. And that's what we need in order for the error, and actually our sign here should have been different because this is the error on the right hand side. We want that to be smaller than the specified value. So we want the error to be smaller than that specified value. And that gives us that interval. Alright, let's go on to example 4. For approximately what values of x can you replace e to the x by this with an error magnitude no greater than 5 times 10 to the negative 4? Alright, so again we want our error to be smaller than this. and we want the maximum value of the third derivative of this, since this is a third order error. So we want the max of f triple prime of c times the max of the absolute value of x minus a. Again, this is centered at a equals 0, and all of that over 3 factorial. Alright, so let's see. The maximum value of the third derivative at c, the third derivative of e to the x is just e to the x, and that's going to take on its maximum value at the endpoint. So I'm just going to replace this with e to the x. The maximum value of the absolute value of x to the third, that's going to take on its maximum value at the endpoint. And all of that over 3 factorial. Okay, so we need to solve this inequality. And we want when e to the x times x to the third is less than or equal to 0.003. I'm going to use my calculator to help me with this. I'm going to graph, because I really don't want to solve this inequality algebraically. We want that error to be less than 0.0030. And so I'm going to set up my window here. To be from, well, do I want to, you know what, let's put the absolute value back up here in this function. I keep missing my cursor. I want the absolute value of this times the absolute value of this. Alright, and now I need to set up an appropriate window. In order to see this, I'm going to set my y max at 0.005, my y min at 0, and I should be able to see these two graphs come into play here. It looks pretty wide for me to perceive anything on the window that I've used, so I'm going to narrow in my x values and look between -1 and 1. Let's see if I get a better. There we go. And now I can find the intersection points of these two functions in order to get the endpoints of my interval. And I'm going to round these out, so I've got -0.152 as one endpoint. Having all kinds of trouble writing. And as the other endpoint, scroll over here, 0.138. And that is the interval on which we expect to have an error less than or equal to 0.0005. Alright, that's the end of this video. See you guys next time. Have a great rest of your day.